All right, ladies and gents, we are starting a new topic today, so we're going to play this and we'll see, you can decide what you think we're going to be doing.
I am lightning. Lightning McQueen has a huge lead. The rookie sensation came into the season unknown, but everyone knows him now.
Oh yeah, Lightning McQueen was on a fast track to stardom until one night. Not in my town, you don't. His life took a detour.
Alrighty, so hopefully you're all shouting at the screen, "Oh, Miss, we're doing speed," and you would be correct. So there are parts of this that are going to have to go into your notes so you can start and stop. So our learning intention for today is going to be to understand and be able to calculate speed. So pause now if you need to and write that in your notes. So at this point in our lesson, I would ask for 2 volunteers, and we're going to see, can we figure out what speed is and what velocity is by demonstration. So you're going to have to bear with me 1 second while I get volunteers from our audience. So I found some volunteers and I want you to look at them and make some observations of what it is that they're about to do. So what do you think? What was it about what they did? So hopefully your observation is that these guys are pretty much walking at the exact same pace, so their speed must be identical. So have a look at this one and decide what's the same or what's different. What's your observation going to be? So hopefully we should have seen that this time the girl is at a much greater speed when compared to the boy. So for this last one, what's different? What's your observation going to be about what's different in this last little clip? So hopefully you have seen here that the boy is veering off to the left and the girl kept going straight. So in the first 2 little movie clips, you saw same speed, you saw differences in speed, and in the final clip you saw the boy go off to the left and the girl go straight. So this parts were about speed and this was about velocity, and we'll have a look in a second and you will hopefully be able to distinguish the differences. So for your notes now, if you have to explain what speed is to the SEC, you have to be able to give them a definition, and the definition is pretty much the maths. So the definition of speed is the distance an object travels per unit time. And we use a triangle to calculate the maths, or at least I use a triangle to calculate the maths and to make it easy. And this is what the triangle looks like. So we put speed in the bottom left corner, we put distance in the top, and we put time at the bottom right. In terms of the units that you could use, there are a couple of different units that you can use, and essentially I put them in the arrangement of the triangle in terms of distance is on top and speed is underneath. So I'm just going to remind you again, if we use the triangle, if we were trying to figure out speed, we would cover over speed and it would be distance divided by time. If we wanted to find out distance, it would be speed multiplied by time. Okay, so if the 2 things you have are arranged like this, it's a division. If the 2 things you have look like this, it's a multiplication. So in terms of our units, they could be meters, what's called meters per second. So that's meters divided by seconds, and it gives you what's called meters per second. This is the SI unit. This is the unit that if you see speeds, this is what they're going to be in SI units. But you'll have seen speeds like on signs on the road in kilometers per hour. So the units are written like this, and essentially if you compare this to this, this is actually the division, but it's written sideways. So it's M divided by S, meters divided by seconds, and likewise kilometers divided by hours kilometers divided by hours, distance divided by time. So the units are written, it's the units for the division, but they're written slashed. So I'd like you now to pause and make sure you have a definition for speed, you've drawn in your triangle, and you've put in what your units of speed could be. So as you know, I have loads of silly sentences to remember things. And my silly sentence will always start here, it will always go up to the top of my triangle here, and it will always end in the bottom right hand side. So my silly sentence is still dinner time, because I love food and I'm always thinking about it. So you can decide that this is going to be your silly sentence, which is absolutely fine, or you decide that you're going to make up a silly sentence that begins with S, D and T. Go mad. In terms of velocity, when we showed you the little movie clip of the boy and the girl, the boy veered off to the left, the girl stayed straight. They were both going at the same speed. So velocity of an object is its speed in a certain direction. Now it's highly unlikely that the SEC will ask you for this definition, but they may use this word velocity when we go to a later part of this particular topic. So I just want you to be aware of it. I like this little joke. So we've said speed is equal to distance over time. A velociraptor, my kids used to be dinosaur freaks, but it's a distraptor divided by a time raptor. So it's the exact same definition for velocity is distance divided by time, distance divided by time. So the units for velocity could be meters per second or kilometers per hour, and they will be a direction involved in somewhere. Has to be. So if you're flying from Dublin to London, your velocity would be 700 kilometers per hour and you'd be going in a southeast direction. So pause now and make sure you have a silly sentence, definition for velocity, units, and maybe an example of what it would look like. So the girl is going to just help us, and the boy, do a little bit of the maths that's involved with speed calculations. So we'll set her off. The boy is timing her. Go, 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 go. Oh, she's so fast the camera can't keep up. So that is the girl. So the girl has, when we timed it, it was an 8-meter distance, and when we timed it, she ran it in 3.1 seconds. So we have speed down here, we have distance up the top, and we have time down the right. And we have here, 8 meters is a distance, so we put the 8 up here. It's definitely going to be a division. The next piece of information we have is 3.1 seconds, which is a time. Ooh. So we're going to put 3.1 here, like so, and you then have to do your division, and the answer you get is going to be your speed that's going to be filled in here. So if you divide 8 by 3.1, you will get 2.6 meters per second. So that is the speed of the girl in this instant. So not to be outdone, the boy had a go. When he did it, he ran 8 meters and he ran it in 2.9 seconds. So again, speed, distance, time. So his distance is 8 meters. So again, it has to be a division. His time was 2.9 seconds. So when we do that piece of maths, we find out that his speed, so this part here, this corner of the triangle, was 2.8 meters per second. So he is just fractionally faster than the girl. So we should say at this point that no children were harmed in the making of those videos. So the last little thing that I would like you to do is, if you had to calculate a distance, can you, in your head, looking at the triangle, what would be the 2 pieces of information that you're going to need? So if you were trying to find distance, you would need to be working out speed multiplied by time, because these would be the 2 numbers that you'd have at the bottom. The units of that then work out to be, because it's distant, meters. And the reason that is because these seconds cancel each other out. If you had to work out time, so you cross out, this is the thing we're trying to find, we would have to multiply, or division, sorry, that we'd have to do. So if we wanted to find out time, it would be distance divided by speed, and our units in this case for time would be seconds. And the reason for that is because these meters cancel each other out. So please bear in mind that the triangle, you can have to find out speed, you might have to find out distance, you may have to find out time. So you're going to do some questions for me now. So question 1, a car traveled 400 meters in 25 seconds. Pause, make your triangle, fill it in, and then we will have a check and see. So I am hoping that you have worked out that 400 meters is a distance and 25 seconds is a time. So it's 400 divided by 25, and that gives us 16 meters per second. This part animated incorrectly, but this is a really straightforward question. If you got this, you're just going, thanks so much, that's so easy. But the Junior Cert examiners are stinkers. So you might have a time in minutes and you have to convert to seconds, or you might have kilometers and you have to convert to meters. Read the question and they'll tell you what answer they want and you have to adjust accordingly. Now this last bit. You have 3 questions that you need to do. So question 1, an athlete runs 1200 meters in 2 minutes. Calculate her speed in meters per second. Seconds, minutes. You have to convert minutes into seconds. Question 2, what distance does a person travel in 2 hours if their speed is 5 meters per second? So this is seconds, this is hours. You need to convert hours into seconds. And the final question, a cyclist moves 20 meters along a track in 4 seconds. Write the letter S beside the speed of the cyclists from these values, and write the letter D beside the distance the cyclist will travel in 2 seconds. So pause now. And welcome back. So an athlete runs 1200 meters in 2 minutes. We have said you need to convert minutes into seconds. So 2 minutes, 1 minute has 60 seconds, 2 minutes must be 2 by 60, so that gives you 120 seconds. And then we're using our triangle. So speed is equal to distance over time, so 1200 meters divided by 120 gives us a speed of 10 meters per second. So give yourself a little tick if you got that right. Second question, what distance does a person travel in 2 hours if their speed is 5 meters a second? So you have to work this out now. 1 minute is 60 seconds. There are 60 minutes in an hour, so that's 60 by 60, and I have 2 hours. So it should be 60 by 60 by 2, which gives me 7,200 seconds. I'm trying to find out what distance. So distance is on the top, so it's a multiplication of speed against time. And when I do that, I get 36,000 meters. In our last part, we had to work out the speed. So we have meters, a distance, 20 meters in 4 seconds. So 20 divided by 4 is going to give me 5 meters per second. And so I'm going to put my S here, write the letter D beside the distance he would have traveled in 2 seconds. So if it's 5 meters per second, you need to multiply this by 2 to find out what he would have done in 2 seconds. And that works out that he has traveled 10 meters per second, or 10 meters in 2 seconds. Okay, so I'm hoping you're getting a tick and a tick. So the last little bits of this, and this is already in your assignment, you need to annotate your notes with rags numbers 1 to 3, which is going to follow in the next screen. You need to complete in your book questions 26.5 to 26.12 in your textbook, not in your portfolio book. To help you, page 255 to 259 in your textbook may help you. And there's going to be a quiz that comes, so you have an assignment is one thing, and there's another quiz, so 2 things to look at today. This is the first part. You're going to put your answers to your homework in this quiz today. So the last screen that I'm going to leave you with is the rag sheet, and what I would like, if you have any questions, you put them on the bottom of this assignment so that we can help everybody. Okay, get in touch. Don't suffer alone. Well done, guys.